Welcome to today's Explainer. I am absolutely thrilled to guide you through this one because we're about to unpack a massive, real game changer in how we use local large language models. Look, for a long time, running an AI locally, well, it kind of felt like having this brilliant consultant trapped inside a glass box. You could ask it all the questions you wanted, but it couldn't actually reach out and touch any of your tools to do the actual work. But today, we're shattering that glass. We are going to dive deep into the Hermes Agent framework, which is a system that literally gives your local AI hands. It completely transforms it from the static chat interface into a fully autonomous task-finishing machine.
To really grasp why this is such a huge deal, we kind of have to look at where the frustration started. The author of our sourced article hit the nail on the head, saying, "My local LLM could not handle an entire task on its own." And wow, is that a feeling a lot of us know too well, right? I mean, you could ask your local model to write a Python script, or maybe troubleshoot a broken Docker container, or figure out how to organize a messy directory. And sure, it would give you a perfectly sensible, really smart answer. But that's exactly where its job ended. It was all theory, zero action. You still had to manually copy the code, open up the terminal, run the commands yourself, hunt down the errors, and feed them right back to the AI. You were basically reduced to a glorified copy-paste middleman.
Okay, let's dive into this. Here is our roadmap for the explainer today. First, we'll cover the local AI problem, then enter Hermes Agent, followed by decoding the agent loop. After that, we'll hit setup and context requirements, and wrap up with real-world use cases.
Starting right off with Section 1, the local AI problem and the bottleneck of chat.
This completely illustrates the core issue we're solving here. A standard chat interface is purely text in, text out. It's just a brain in a jar. You ask a question, it generates text. But an agent framework shifts this entire dynamic to task in, action out. Think of it as the brain versus the hands. Now, cloud-based coding agents, they've had this capability for a while. They can open files, run commands, check their own work, and even correct their own mistakes without you acting as the human bridge between the model and the terminal. The real problem we faced was bringing that exact same hands-on autonomous workflow to the models running locally, right on our own hardware.
Which brings us to Section 2, enter Hermes Agent, an open-source harness.
So Hermes Agent, which was built by Nous Research, isn't actually a new model. It's more like a harness that surrounds your existing local model, and it arms your AI with a very specific, very powerful set of tools. It gives it the ability to run terminal commands, read and edit files, manage active processes, search the web, and it can even control a web browser. Hopefully for research, and not just to get distracted browsing Reddit. It also features persistent memory across your sessions. Now, why does all this matter? Well, file access lets the AI inspect your actual project instead of blindly guessing what's in there based on your prompt. And terminal access, that allows the model to instantly run the script it just created. So it doesn't replace your model, it just gives it a fully equipped tool belt.
Moving into Section 3, decoding the agent loop. Let's look at how the AI actually works autonomously.
So, the absolutely crucial point here is how Hermes handles the work surrounding the model. When you give Hermes a task, it kicks off this four-step loop. Step 1, the model chooses a tool based on whatever you prompted it to do. Step 2, Hermes acts as the hands and physically executes that action, like running a script in your terminal. Step 3, Hermes takes the output of that action and feeds it directly back into the model. And Step 4, the loop continues. The model inspects the result, decides what its next move is, and just keeps working until the task is completely finished, or until it hits a wall and needs to ask you a question. And here is the absolute magic part of this. If a command fails, the error message goes straight back to the model so it can try a totally different approach. Zero human copy-pasting required. It's amazing. All right, Section 4, Setup and Context Requirements. Let's talk about connecting Ollama or LM Studio.
Now, you might be sitting there thinking setting all this up is going to be an absolute nightmare, but there are actually very few things to configure. There are dedicated desktop installers ready to go for Windows and Mac OS. And if you're on Linux or using WSL, it's literally just a single curl script. Once you have it installed, you just select the custom endpoint option inside Hermes. Say you're running an Ollama server on the same machine, you just point it to localhost:11434. You can completely skip the API key and just type in the exact name of the model you've already downloaded. It is incredibly straightforward.
But, and this is a massive but, so listen up. There is one setting you absolutely cannot ignore. 64,000. That is the magic number. You must have a context window of at least 64,000 tokens for this entire framework to function correctly.
So why 64K? Well, because the agent framework is incredibly resource-heavy when it comes to memory. That context window has to hold the Hermes system prompt, all of those complex tool definitions we talked about, plus the running history of all its previous actions while it works through that agent loop. Often, Ollama loads models with a much smaller default context window. If you don't adjust this, the model is going to fail. To fix it, you simply start Ollama using the environment variable Ollama underscore context underscore length equals 64,000, followed by Ollama serve. This ensures your local model actually has the memory capacity to use the tools it's been given. Oh, and you also need to make sure your specific model supports tool calling. Otherwise, it's just going to print out tool requests as plain text instead of letting Hermes actually execute them.
Let's wrap things up with Section 5, Real-World Use Cases. Let's put Hermes to work.
Let's bring all of this theory together by looking at two super common, highly annoying tasks. First up, you've got a Docker container that just keeps restarting. Instead of guiding the AI step by step through the process, you just hand Hermes the whole job. It autonomously checks the running containers, reads the error logs, inspects your Docker Compose file, and identifies the problem. It can even edit the file and restart the container itself to see if it stays online. Or think about a folder full of just terribly named files. Hermes will inspect the actual file names, write a script to organize them, run a dry test to make sure it won't absolutely ruin your data, and then apply the changes. All while you just sit back, sip your coffee, and approve the final result. The AI does all the busy work.
And it's also incredibly useful for those smaller jobs, especially if you're running a home lab or a server. You can ask it to find out what's eating up all your storage, and it'll actively scan the directories to show you the largest files. For all you Home Assistant users out there, it can jump into a configuration file, find that one tiny infuriating YAML indentation error, fix it, and validate the file. And honestly, my favorite part, if you want a new automation, it reads your existing configurations first. So instead of spitting out some generic textbook example that you have to heavily edit anyway, it writes the new automation matching your exact existing formatting. It's brilliant.
Now, to be fair, Hermes Agent isn't the only player in town. You can achieve this exact same autonomous workflow with alternatives like Claude Code, Aider, or OpenCode. The crucial takeaway from our source material today isn't that you absolutely must use Hermes. It's that as long as you have a capable, open model, you just need to wrap it in a harness. Whether you use Hermes or Aider, the point is you are moving away from passive chat and towards active, local execution.
Which leaves us with this final thought. We've seen how wrapping a local LLM in an agent framework completely transforms it from a simple text generator into this autonomous worker that can read files, write code, test its own solutions, and actually fix its own errors. The glass box is officially broken. Your local AI finally has hands. So looking at your own projects, your own servers, your own messy, unorganized folders, what complex task are you going to hand over to your local AI tomorrow? Thank you so much for joining me for this explainer, and happy experimenting.